Hey guys, welcome to this video on the central limit theorem. So, in general, knowing the mean and standard deviation of a random variable x is insufficient information to calculate probabilities. We can calculate probabilities in a special case where x is normally distributed. However, not all the time things are going to be normally distributed. The central limit theorem gives us a remarkable result concerning the normality of the sample, regardless of the normality of the original variable x. So what that's telling us is that even though overall it may not be normally distributed, if we take a sample, we're going to find that we might find it's normally distributed. And this is what the central limit theorem is going to hopefully do for us. So suppose that x is a random variable which is not normally distributed. X will have a mean and a standard deviation for a sufficiently large value of n. So the key here is as n increases, we're going to find we've got a mean and a standard deviation. For a sufficiently large value of n, the distribution of sample means, which we know is just xn with a line above it, of size n is approximately normal with a mean and a standard deviation of the standard deviation divided by the square root of the number of samples that we're taking. The larger the value of n, the better the approximation is going to be. So remember, this is just going to be an approximation. How do we actually calculate this? Well, we're going to use our calculators for it. I'm not going to show you exactly how to do this on your calculator, but I will show you what values you're going to need to be putting where. So please get this written down. Pause the video, get this written down, and then we'll look at a quick example and how you're going to put this into a calculator. Alright, so I'm going to go through two basic examples here. So a random variable x has a mean of 60 and a standard deviation of 4. A sample size of 45 is taken from x. So from all these random variable x, we're taking a sample of 45. So I can write that down as x. Let's write it down as n being equal to 45, because n is really our number of samples. So n equals 45. We can apply the sample is a size 45, we can apply the central limit theorem. What this is going to be, in your calculators, you're going to use normal CDF, and in there you're going to put down your lower value, or your lower bound, as being 1 minus 1 by 10 to the power of 99. Your upper bound in this case is going to be, so let's go lower, upper, let's make sure we write it properly. We're told that in this case we want to find the probability that the mean of the sample is less than 59. So in this case we're going to use 59 as our upper, because we want to know from everything less than 59, so 59 down, and remember that the 1 minus 1 by 10 to the power of 99 is the largest number our calculators can take. What we're going to do now, our mean we're told is 60, so, but a standard distribution, our standard deviation, we're told is 4, but you're not going to put this 4 in. if we're looking at the central limit theorem, we've got to use the standard deviation of sampling means, which we spoke about in the last video. And we know that this is standard deviation divided by the square root of n. And we can just plug this straight into the calculator. So for our our standard deviation, we're going to put in 4 divided by the square root of 45. So once we put all of that in, we're going to let the calculator do its work and hopefully come up with an answer. And we could write this out as the probability that the mean is less than 59 is going to be roughly equal to, and in this case our calculator should give us 0.0468 roughly. That's really it for finding or using our calculators in this example. Let's look at a real life example now. So what we've got is the contents of soft drink cans is normally distributed with a mean of 378 millilitres. Standard deviation being equal to 7.2 millilitres. Find the likelihood that an individual can contains less than 375 mils. How we're going to do this is the same way that we've been doing it previously with normal CDF. We're just going to chuck in the values here that we're given. So the probability that X is less than 375, we'll plug that into our calculator. So again, normal CDF. Our lower, upper, mean and standard deviation. We're just going to plug in, like we have been doing all along, of minus 1 by 10 to the power of 99. Our upper in this case is 375. Our mean is 378 and our standard deviation of 7.2. Plug all those values in, let the calculator do its thing, and this is roughly going to be equal to 0.338. Now, that's overall, but we're talking about the central limit theorem here. We want to know sampling. So, the next part of this example, a box of 36 cans has average contents less than 375 millilitres per can. So, X, our sample mean of 36 cans, our mean of this is still going to be equal to 378, but our standard deviation this time is going to be equal to 7.2 divided by the square root of 36. Again, we plug these into our calculator, except our lower, our upper, our mean are still going to be the same. The only thing that's changing here is our standard deviation. We're going to use this one instead. So for this example, you're going to have lower still being the same as minus 1 by 10 to the power of 99. Our upper being equal to 375. Our mean being equal to 378, but our standard deviation is going to be equal to 7.2 divided by the square root of, not 45, 36. So we could write this down as a probability that our mean, X, or 36, because we're taking 36 cans, is going to be less than 375, is roughly going to be equal to 0.00621. So there's an approximately a 0.6 chance of getting a box of 36 cans with average contents less than 375 millilitres per can, compared with a 33.8% chance of an individual can having contents less than 375 millilitres. So this is when we're starting to compare and look at real world examples. So we know that this here is 33.8% and here is 0.621%. So again, there's approximately a 0.6% chance of getting a box, an entire box, so every can in that box with average contents less than 375 millilitres. So if we work out the contents of all of those cans with it being less than 375 millilitres, there's a 0.6% chance. If we just pick out a random can out of all of the cans that are manufactured, there might be a 33.8% chance that that individual can has contents less than 375 millilitres. That's it for the central limit theorem, and that brings us to the end of this topic. Hopefully you guys have got something out of it. If you've got any questions, please ask. As always, thanks for watching, and we'll see you next time.